Hey everybody, good morning. I'm Tim Brzezinski. In this screencast, I'm going to show you how to create yet another formative assessment GeoGebra resource that provides the student with instant feedback. I did one last night, a very basic one where we added 2 integers, but in this one, it's going to be a little more advanced. And the objective here is going to be, for this resource we create, what we're really going to do is create a simplified version of this one right here. Okay, where basically we click a button that says new problem, and here it displays a slope. And what we want to do is move these points around, have the student move the points around so that they graph the line with that specified slope. So in this case here, for example, right, slope is 5/2, 1, 2, 3, 4, 5, 1, 2, right, and that is correct. Okay, we're going to learn how to create something like this now. So I have GeoGebra Classic 5 opened. Whenever I create personally, I like to create in the software version on my MacBook computer. But I know many people that create their own resources online. I've done so. Not often, but I do. But I tend to create in the software mostly. But we're going to start with a blank canvas right here. Okay. In fact, we can actually right-click and hide the axes because we really don't need those. Okay. And before we even get started, I'm actually going to do this as well. I'm going to right-click, go to Graphics, and basically for the x-axis, I'm going to actually lock for the grid. Let's go to the grid first. I like to just show major grid lines, maybe look a little neater. And where the x-axis is, I'm going to lock the distance in at 1, enter, here, y-axis 1. Okay, and I want to do this so that way when I zoom out or zoom in, the scaling doesn't change. I literally want every distance between, I want every edge of every square to be 1 unit long for this particular resource that I'm building. Okay, so now let's actually, we need to use the random number generators to create a slope. So I'm going to call this the n list for numerator. Sequence. I could type all the numbers out, but I'm too lazy. All right. Sequence. All right. I. What this is doing is creating a list of numbers for me, and the list of the expression is I. The index, the variable here is I. I'm going to start at -10, end at 10, and the increment's going to be 1. All right. So what that does is it creates a list we call n list, what I'm going to call the numerator list. I'm going to have GeoGebra randomly choose an element from this list here, and that's going to serve as the numerator of my slope ratio that I'm going to generate. Okay. Now, I'm going to make a denominator list, but the one thing is I don't want undefined slopes. I don't want to have a denominator of 0 here. So I could actually type in, you know, everything like -10, -9, all the way up to 10 without putting the 0. I like to work. I like to try to work a little smarter, a little less harder if I can. I don't always, but I'm going to actually just call d left equals sequence. What does left mean? You'll see. Okay, I, -10 to -1. And we'll increment by 1s. So I'm going from -10 to -1 here, right here, right? And I'm going to call the next list d right equals a sequence, right? I. Now, if I call this 2i, it would generate even numbers for me, right? This first one here, -10. I'm sorry, 1, 10, 1. Notice here, these are all negative numbers. These are all positive integers here. So what I'm going to do is I'm going to call the official D list from which I'll choose my denominator. I'm going to take the union of these two lists. I'm going to take the union of D left and D right. Like that. See what I mean? So notice here that my denominator list does not have a 0 in it. So I'm going to tell GeoGebra to randomly choose a number from the numerator list, randomly choose a number from the denominator list, and I want you to divide them. That's how I'm going to form my next problem when the student hits new problem button. That's what it's going to do. So most of us teachers like to define slope as m. So m is going to be defined as random element. So you can choose a random element from a list. Random element n list divided by random element D-list. That way, I will never have a denominator being 0, if that makes sense, because there's no 0 in the D-list, the denominator list, right? Enter. And there's my number right there. I don't have to worry about my lists anymore. So now, next one I'm going to do is I'm going to create, now it did that, I'm actually going to create a button here to generate a new problem, right? And the key, as I did in the screencast last night, anytime you have any kind of randomizing going on, you want to make new numbers for the random variable. You type in update construction with a capital U, capital C, open bracket, close bracket. That's it. Hit OK. Set the move arrow. See here, if I hit new problem, it's making new problems here. Now the important thing that I need to do is actually use the fraction text command to make it a simplified ratio. Otherwise, it's going to come out as decimal when I type it in words, right? So, but we want the exact ratio there. Fraction text M. And look at that. It actually creates that fraction text there, right? Which I'm going to hide from the graphics view. But watch this number 1 here. See how it changes? That's what I want the student to see when they end up doing their problem. So now I go ahead and type directions. I go to a text. I say, hey, graph, move the 2 points. We haven't plotted the line yet. Move the 2 large points around so the line displayed as the given slope. Exclamation mark. So those are my directions for the student. I'll put them right over here, say. All right. And now over here, I'm going to make another text here. I'm going to use LaTeX. Now, if you don't know what LaTeX is like math language, like math type. But I put LaTeX because I want to just say, I could actually put here text slope, okay, equals, see, and if I didn't put the slash text here, it would just look all kind of cursive-y here. It's what preview is. Slash text slope equals, and now I can just go to my objects and type in text1, see your text1 here, or I could just touch it right here. I touch text1, see how it appears, and I hit OK. Let's move that. So we want the slope of this line to be -3/4. I hit new problem. See how it's making new problems for me here? Notice my denominator is never going to be 0 because I made it from the D list not have 0. So now, let me right-click on Fix the Object, and then fix it there. So now we need to make a line here. Let's graph a line. We have to put a line for the student to move around, right? The line is determined by 2 points. Put it right there. Okay, I'll select the move arrow again. I don't need to show the label. The label's F, so I'll right-click and uncheck Show Label. Now, any points that students can drag around, I like to make obnoxiously large. And I don't need to show the label. I could make hidden, check on the point. Go to AA here, make hidden, right? Now, another thing teachers have asked me over the last couple of years is how do you actually force it to only go on grid lines? Because you locked every distance at 1, right? When you did graphics before, that's easy too. Just go to the magnet and hit Fix the Grid. Check that out. Now I'm forced to have a rise and a run here that are both integer values here. Okay, let's measure the slope of this line now. Okay, now the student's not going to see this, but we're just doing this for our purposes right here. Now the slope of that line we know is 3/5, right? But let's notice the slope of that line is called m sub 1. So what I'm going to do now is create a correct text box that's going to appear if the student graphs correctly. And click Properties, Color. Let's make the background color some nice hot pink there, and we'll make the letters, the foreground color white. You can make this large. If you see any of my resources, they kind of look like the correct box sort of looks like this, but it doesn't have to be, obviously, right? And so what's going to happen? This sign is going to appear whenever I graph the line correctly. So I'm going to actually right-click on my slope and hide it because I don't want to see it now. Or actually, I'm not going to do that yet. When is this correct box going to appear? Let's right-click on the box, go to Object Properties. And under the Advanced tab, condition to show object. That's the most important thing. When do I want this to be shown? Remember, the student can move these 2 points around, right? Just like so. The slope is going to change as the student does, but when is this going to show up, this box? Well, think about it here. Got to touch the box. That's going to show up whenever this slope m sub 1, right? I'll type in m sub 1. Again, this is the properties box for the pink correct box here. It's going to show when that slope m sub 1 equals. That means is it equal to? Remember, double equals is a Boolean logic operator. Like, is it equal to? True or false, right? And what's the number called? The slope we defined as 1/5. So m sub 1 equal m. And then hit enter. Notice how it disappeared. That text box is going to show when that brown slope is equal to that number that GeoGebra generates at the click of a button. So let's try this now. Okay, now the student's not going to see this. I'll unshow the object. I want to make sure my students know how to graph the slope of a line just by mere inspection, by seeing it and by moving the points around. So let's do this, right? And then rise of 1, 1, 2, 3, 4, 5. Oh, correct. What if I did 2/10? Rise 2, 1, 2, 3, 4, 5. See, as long as the slope of the line is what it is, that's it. Okay, now I can actually close this out. And I'll stop it here because basically now you know how to upload to GeoGebra's resources page. And you could just put your directions there and format it the way you want it. So that's how I create a formative assessment resource. A little bit more involved. That involves students actually, let's do a -1 here just to make sure it works. -2/3, right? Down 2. And remember, students will like, oh, and students will like every possible error in an activity like this. But the beautiful part here, this definitely beats a CUDA worksheet. Why? Because the students will know instantaneously if they got it right or not. So obviously, well, gee, there's something wrong here. Light bulb should go off over the head. It's like, oh, wait a minute, I'm doing something wrong here. I can't move on. Or I shouldn't move on, right? Rise it to -2, 1, 2, 3. There we go. And I could generate as many problems as I would like here. All right. So that's how we can do something like that. And then you upload it, and then you're good to go. And you can assign it to as a warm-up for your students, say, coming in. So that's how I did it, that slope one there. If you like what you see, feel free to subscribe. I'll be doing some more GeoGebra screencasts later on this week, how to create a custom toolbar with like only a few tools showing. Also how to create your own custom tool. All right, so we'll be doing lots of stuff there. I'm Tim Brzezinski. Thanks for watching, and have a great day.